Good evening all. You're welcome to our today's tutorials. Today we'll take a look at physics. And the topic is motion. The topic for today is motion. All right, so as usual, we look at some questions. Our reference book for today, our reference books for today are New School Physics for Senior Secondary Schools, 2016 edition by M.W. Anyakoha, PhD, and the Prep 50 Physics UTME past questions. So we are going to pick questions from this book and take it off from there. Okay, the question says a train has an initial velocity of 44 meter per second and an initial acceleration of minus 4 meter per second squared. Its velocity after 10 seconds is A, 2 meter per second, B, 4 meter per second, C, 8 meter per second, D, 12 meter per second. The question source is JAM 1983, question 15, as stated in our reference material for today. All right, let's solve this question. Solution. To solve this question, we first of all understand the question and look at the laws of motion, linear motion, equation of linear motion that will suit the question. First of all, we should identify the variables, the parameters in the question. So identify the parameters in the question, then we now look for the law of the equation of motion that has business with these parameters. Okay. So, first of all, we have initial velocity. So we have u. So let's write u out. Let me write the values at once. We have initial velocity to be what? 44 meter per second. Then you have acceleration to be what? Minus 4 meter per second squared. Its velocity after 10 seconds. So the velocity after 10 seconds is the final velocity. So V is the final velocity. It's equal to squared is equal to u squared plus 2as. And we also have that s is equal to ut plus half at squared. Half at squared. We also have that this is equal to v plus u over t. I hope I'm correct. The one that has to do with the average average distance, average velocity over time. Because velocity is equal to distance over time. So if velocity is equal to the distance over time, that means that this is average velocity or average speed, sorry. So this is equal to what? Vt, and average velocity is speed is equal to v plus u times t over 2. Yes, it's v plus t over what? 2. So these are the equations of motion. So let's look at this given parameters and look at the one, find out the one that's the equation that we can use, the equation that contains all these parameters. That is the one we are going to do what? Use. Let's start for the first one. Distance is here, but there's no distance here, so we will not use this one. Final velocity is here, there is final velocity here. Initial velocity is here, there is initial velocity here. Acceleration is here, there is also acceleration. Time is here, there is also time. So let's keep it, this one fits in here, but let's keep it careful. Let's check others. Final velocity is here, there is final velocity. Initial velocity is here, there is initial velocity. Distance is here, but there's no distance. And time is here, but there's no time. So this one doesn't go. Time is here, there is time. Acceleration is here, there is acceleration. Time is here, there is time. But here we have final velocity is here, but there is no final velocity. So this one doesn't go. Now, so the only equation that suits this is this one. So we're going to use it to solve this question. So V is equal to what? U plus what? AT. So let's substitute These for the values of this. So that means that V is equal to initial velocity is what? 44 meter per second. We have 44 meter per second plus acceleration is what? Minus 4 meter per second squared. So we now say, of course, if you put minus here, okay, let me just minus 4 meter per second squared times what? Time, which is 10 seconds. 10 seconds. So this second here will cancel 1 second. Remember that this is under. So this second here will cancel 1 second here. So we have meter per second here. Minus 4 times 10 is minus 40. So we have 44 meter per second. This minus will take care of this plus. So everything will become minus. Minus 4 times 10 is what? 40. We are left here with meter per second. Remember that 1 second here cancel this second one. This second here cancel one of the seconds here. So we have meter per second. So 44 meter per second minus 40 meter per second is equal to what? 4 meter per second. So the answer to this question is what? 4 meter per second. So let's look at the options. Option A says 2 meter per second is not the answer. Option B says 4 meter per second. I agree with option B. Option C says 8 meter per second. I don't agree. Option D says 12 meter per second. I don't agree. So the answer is what? B, 4 meter per second. So the answer to JAMB 1983 physics question 15 is B, 4 meter per second. Is B, 4 meter per second. 4 meter per second. Okay, so if you have any question here, please feel free to drop your questions on the comment section. Please, if you are joining us, please subscribe to our YouTube channel, follow me on Facebook, and share these lectures with your friends so that they can join us. You can join us on our lecture today on physics. All right. So as I leave the questions for us to digest it, I'll give like 1 minute for us to look at it again. Then I'll claim it and go to the next question. Has elapsed, let me clean the board and go over to the next question. Okay, let's look at this question. The question says, a particle starts from rest and moves with a constant acceleration of 0.5 meter per second squared. The distance covered by the particle in 10 seconds is A, 2.5 meters, B, 5.0 meters, C, 25.0 meters, D, 50.0 meters. JAMB 1988, question 6. Let's solve this question. Solution. Alright, as usual, we write out the parameters and their values here. Then check the equations of motion and find out the one that accommodates all these parameters. That is the equation we're going to use to solve this question. Okay, let's go. The first parameter here is what? Acceleration. So A is equal to 0.5 meter per second squared. The next one is distance. Distance we don't know. The next one is time. The time is what? 10 seconds. So we are told that it started from rest. So when it's resting, at that rest, the initial velocity is 0, even though they did not mention initial velocity. But at rest, initial velocity is what? 0. So U is 0 meter per second. All right, let's go. Let's look at the equations of motion that accommodate all these things. The first one, I have cleaned them. Okay, let me write them out here, so I don't have to clean them again. We have that V is equal to U plus AT. We have that V squared is equal to U squared plus 2AS. We do have that S is equal to UT plus half AT squared. We do have that S is equal to U plus V all over 2 times time. Let's now look at the one that we can use to solve this question. Let's start from the first one. There is V here, but there's no V here. So this one is cancelled, is out of the game. The second one, there's V here, there's no V here. So it's done too. This third one, there's S here, there's S, okay. There's U here, there's U, okay. There's T here, there's T, okay. There's A here, there is A. Perfect. This one follow. This one can be used. But let's check all of them. The next one, there's S here, there's S here, okay. There's U here. Half times. Let's cancel out the unit first. This 10 seconds squared is okay. Let me just bring it out. Half times 0.5 meter per second squared times 10 seconds squared is 100. 10 times 10 is 100. 100 second squared. This second square will cancel this second square. Remember that this is per second square. So every second is gone. So we are left with what? Meter, which is the unit of what? Distance. So let's go. 0.5 times 100. That is half of 100 is what? Half of 100 is what? 50. Then half of that 50 is what? 25. The unit is what? The answer is what? 25.0 meters. So let's look at the options. Option A says 2.5 meter is not the answer. Option B says 5.0 meters is not the answer. Option C says 25.0 meter is the answer. But let's look at this option D. Option D says 50.0 meter is not the answer. So the answer to JAMB Physics 1988 question 6 is B. So is C, 25.0 meters. 25.0 meters. 25.0 meters. So I'll give us like 2 minutes to look at the questions again, look at what we solved. If you have any question, please drop it in the comment section. Drop it in the comment section. You can also chat me up on WhatsApp. My WhatsApp line is +234 813 6. Sorry. Either this or 234 any of this, wherever you are watching from the worldwide, you can send your questions through this. Any question on this topic, you can send it and we will discuss with you, agree, and solve it. All right, so we have 2 minutes to just go to the question and drop your question if you have any. our 2 minutes have elapsed. So let's clean the board and go to the next question. The question says, a body starts from rest and moves with uniform acceleration of 6 meters per second squared. Full stop. What distance does it cover in the third second? A. 15 meters. B. 18 meters. C. 27 meters. D. 30 meters. JAMB 1992 question 4. Be careful with this type of question. The question says, what second? In this 10 seconds doesn't mean in 10 seconds. Please, let's be careful here. In the third second doesn't mean in the third second doesn't mean in 3 seconds. They are not the same thing. So if you want to find the distance covered in third second, you first find the distance covered in in 2 seconds. In 2 seconds, and keep it. Then find the distance covered in 3 seconds. Because third second, in the third second, lie between the 3 seconds and 2 seconds. So find the distance covered in 2 seconds and distance covered in 3 seconds. Then subtract the distance covered in 2 seconds from the distance covered in 3 seconds. Then you can find the distance covered in the third second. Alright, let's go. So let us now find the distance covered in 2 seconds. But before that, I will list the what? The parameters and find out the equation we should use. That's why I didn't claim this equation. So let us now we are told that the body starts from rest. That means that the initial velocity is what? 0. So U is what? 0 meter per second. Another parameter is we are given acceleration to be 6 meter per second. So A is 6 meters per second square. A is 6 meters per second squared. Then we have distance here. That's what we are looking for. S, we don't know. We are looking for it. Then time, as I said before now, in the third 10 seconds is not in 3 seconds. Please, when you hear in the 10 seconds, it means in between the what? The after after 2 seconds and the 3 seconds. So you lie between. So you find the distance in 2 seconds, keep it. Find the distance in 3 seconds, keep it. Then you can now subtract and get the distance covered in the third second. Now, the time here. Remember, we want to first find the distance covered in what? 2 seconds. Why T2? Let me say T2 meaning distance, the time. Okay, let me just use T1, no problem. It's 2 seconds. This T1 represents the time, the first time, which is in 2 seconds. Then T2 is what? 3. Let's look at the equation that we can use to solve this question. This one has V, but there's no V here, so we cannot use this one. This one also has V, no V here, so we cannot use it. This one has S, there is S here, good. It has U, there is U, good. It has T, there is T, good. It has A, there is A, good. So we can use this one, but let's check this one too. This one has S, there is distance S, but this one has V, final velocity, but there is no final velocity here, so we cannot use this one. So we are going to use this one. So we have S is equal to UT plus half AT squared. But remember, I said we should find the distance covered in 2 seconds. So S2 is equal to 0, here is 0 meter per second times time in 2 seconds is 2 seconds plus half. Acceleration is what? 6 meter per second squared times time. Time here is 2 seconds, so we have 2 seconds all squared. Because of this 0, everything here is 0, so it will go. So we are left with what? Half times 6 meter per second squared times 2s squared is 4 seconds squared. This second squared we take care of this second squared, so everything time we go. We are left with what? We are left with what? Unit of distance, which is meter. So let us multiply out. 6 times 4 is 24. 24 meter. 6 meter times 4 is 24 meter. 24 meter divided by 2 is 12 meters. So the distance covered in 2 seconds is 12 meters. So let's find the distance covered in 3 seconds. Permit me to clean the questions from here. So, because of space. All right. So let's find the distance covered in 3 seconds. So S per second squared times 3 seconds squared is 9 seconds squared. This second squared will divide the second square. We're left with 6 meters. So this 2 will divide 6 meters. We're left with what? 3 meters. 3 meters times 9. Well, the answer is what? 27 meters. So the distance covered in 3 seconds is 27 meters. While the distance covered in 2 seconds is what? 12 meters. But we're looking for distance covered in the third seconds. So distance covered in the third seconds, S third, is equal to distance covered in 3 seconds minus distance covered in 2 seconds, which is 27 meters minus 12 meters, which is what? 15 meters. So the distance covered in the third second is 15 meters. 15 meters. So let's look at the option. Option A says 15 meters. I will tick it. Let's look at the other ones. 18 meters, no. 27 meters, no. 30 meters, no. Be careful. If you're not careful, you will think that in the third second is certain as in 3 seconds. That is the same thing. So if you're not careful, you go and think what? 27 meters. So the answer is what? 15 meters. As usual, I'll give another 2 minutes for us as make this question. If you have any question to ask or anything here that is not true, feel free to comment on the send it on the comment section so we can nobody knows it all. This is also an interactive class. If you think there's something here that is not in order, feel free to drop your comment and I will attend to that. And I will attend to that. So, but the answer is here is what? 15 meters. So we have 2 minutes to do that. 2 minutes. Thank you. has elapsed. So let us now clean the board and go to the next question. Let's look at the question. The question says, an aeroplane lands on a runway at a speed of 180 kilometers per hour and is brought to a stop uniformly in 30 seconds. What distance before coming to rest? A. 360 meters. B. 540 meters. C. 750 meters. D. 957 meters. JAM 1993 question 5. JAM 1993 question 5. Okay, as usual, let us list the parameters and their values. We now look at the equations of motion we have there and now find the one that contains all the parameters in the question, both the hidden parameters and the one that is what not hidden. So let's start. First of all, of course, you know that when the aeroplane lands, it first lands with a particular speed, lands before it starts moving on the what runway. It doesn't land beam like that. It lands first, then continue on the runway. It lands and as it lands, continue until it will stop. It doesn't land and stop like this. No, it lands. It's unlike helicopter that just lands like that. But aeroplane lands here, then keep running on the runway until it will stop. The question say that it lands on the runway at a speed of 180 kilometer. So this speed of 180 kilometer is the speed with which it lands on the runway and continue going. So initial speed is that 180 kilometer. It keeps moving. As it's moving now, this speed will keep going down until this speed becomes what? Zero. That's when it will now stop. And it stops at final velocity of what? Zero. The initial velocity with which it landed on the runway is 180 kilometer per hour. And as it's going, it will be decelerating, retarding, going down until the velocity becomes zero. That is the final velocity is what? Zero. It will stop. And it stops in 30 seconds. So let us now write out the parameters. So initial velocity is 180 kilometer per hour. Final velocity is what? Zero. Is zero. 0 kilometer per hour. Now, I left this space because we are giving time in seconds. So I want to use it to convert I want to use it to convert force. This space, I want to use it for some conversion. That's why I left this space. So the other parameters here is what? Time, which is what? 30 seconds. 30 seconds. Now, let's look at which of the equations. Okay, we are looking for what? Distance. So which of the equations contains all this? Let me write distance here. We are looking for what? Distance. So which of the equations do we now use? Let's start again. V is here, good. U is here, good. A is here, which is acceleration, but there is no acceleration here. So we cannot use this first one. Let's go to the second one. V is here, and V is here, good. U is here, which is initial velocity, and there is initial velocity here, wonderful. Acceleration is here, which is A. There is no acceleration here, so we cannot use this one. S is here, good, beautiful. U is here, okay, I agree. A is here, but there is no A here, so we cannot use this one. The second one says, this last one says, S is here, and there is S here, good. U is here, there is U here, good. V is here, there is V here, good. T is here, there is T here, beautiful. So we're going to use this last one. So S is now equal to initial velocity plus final velocity all over 2 times time. So, but before we start substitution, I want to convert. Here is in kilometer per hour, while the time is in seconds. Time here is hour, so we need to convert everything. We convert it to meter per second. Let's move this to meter per second. And how do we do that? Okay, this is 180. We have 180 kilometer. Remember, 1 kilometer is equivalent to what? 1,000 meters. So if you want to move this numerator, remember that this is just like saying 180 kilometer over 1 hour. Remember, it's just like saying 180 kilometer over 1 hour. So if we want to convert this now, we could convert the numerator to meter, we convert the denominator to seconds. So let's go. We have 1 kilometer is equivalent to 1,000 meters. So this is certain as saying also 180. Remember that, also remember that 180 kilometer is certain as saying 180 times 1 kilometer. It is certain as saying 180 times 1 kilometer. So, and if 1 kilometer is 1,000 meters, that means any place you see 1 kilometer, you replace it with what? 1,000 meters. So if you put 1,000 meters here, this becomes 180 times 1,000 meters. All over 1 hour. We have 30. We have 1 minute is 60 seconds, and the 1 hour is 60 minutes. So if 1 minute is 60 seconds and 1 hour is 160 minutes. So any place we see minutes, we replace it with what? 6 seconds. So that is 1 hour becomes 60 times 60 seconds. So 1 hour here is what? 60 times 60 seconds. We are good to go. So let's cancel out. If 60 divided 180 is 3. Is 3. This 3 here divides 60 denominator. And if 20 divides 1,000, we have 50. Because 0 cancels 0 is we have 100. 2 divided 100 is 50. So this thing is set now. This thing now is what? 50 meter per seconds. 50 meter per seconds. So 180 kilometer per hour. So we have gotten our what? Initial velocity to be what? 50 meters per second. Final velocity is 0 kilometer per second. So it doesn't matter because everything is still what? 0. So this can also be what? Be regarded as what? Meter per second. So let us now substitute all these things in this equation and find our what? S. So that means S is now equal to what? Final velocity, initial velocity is what? 50 meter per second plus all over what? 2 times time is what? 30 seconds. Permit me to clean some part of this place, this question. So let us continue. S is now equal to 50 meter per second plus 0 meter per second is 50 meter per second. So we have 50 meter per second over what? 2 times what? 30 seconds. Remember that this is per second. So this per second will cancel the second. So we are left Okay, our time has elapsed. Let's solve. Let's go to the next question. Let me clean the board. All right, let's look at the question. The question says, a motor vehicle is brought to rest from a speed of 15 meters per second in 20 seconds. Calculate the retardation. Calculate the retardation. A. 0.75 meter per second squared. B. 1.33 meter per second squared. C. 5.00 meter per second squared. D. 7.50 meter per second squared. JAMB 1994 question 5. JAMB 1994 question 5. All right, let's solve the question. Solution is already on the board. As usual, let us write out the parameters and their values. The first parameter here is, we are told that the vehicle was brought to rest. That means the vehicle was moving with a particular speed and was brought to rest. So it has an initial velocity, but it brought to rest, meaning that the final velocity is now zero, because the velocity will become zero for you to stop. So the final velocity is what? Zero. Initial velocity is there. Good. So that speed with which it was moving is the initial velocity, which is, so that not, please, speed and velocity are not exactly the same thing. Please, speed is a scalar quantity, velocity is a vector quantity. Speed doesn't have direction, it has only magnitude. Velocity has the both direction and what magnitude, because sometimes I mistakenly misplaced two of the please, they are not exactly the same thing. So We are talking about speed here. The speed, the initial speed is what? 15 meter per second. So U is 15 meter per second. Then, then final velocity is zero because the vehicle was brought to what? Rest. Final velocity is 0 meter per second. It has time. Time is what? Time is 20 seconds. We are given retardation R. Retardation R is negative of acceleration. So the retardation is minus what? Minus what? A minus acceleration minus A. That's what we are looking for. We are looking for this. So it's negative of what? A. Okay? We are looking for R, which is negative of A. It's the same value but is negative. So what this will only change the sign in this equation. The effect of this is that it will change the sign in the equation. Let's go. So let's take each of the equations that we can use to solve this question. Let's start from the first one. There's V here, there's V here, correct. There is U here, there is U here, correct. There is A here, even though it's negative, but there's still A here, correct. There is T here, there is T here, beautiful. What of the second one? There is V here, there is V here, there is U here, there is U here, okay. There is A here, there is A here, confirm. There is S here, which is distance, but there is no distance here, so this one will not fly. Let's go to the next one. There is distance here, but there is no distance here, so this one will not go. There is distance here, but there is no distance here, so this one will not go. So the one we are going to use to solve the equation is the first one. So we say that V is equal to what? U plus what? AT. But because the relation here is the same, it's also the same, it also has the same A, but it will change the sign of this thing. Please just note that. So because of this effect of the retardation, the sign of this will change. We have U plus minus what? AT. So we now find this A. If we find this A now, it becomes what? The retardation. Good. So let's make A the subject of the formula first before we can solve this, so that it will be easy for us. So we have that if you make A the subject of the formula, or let's substitute straight and solve our question. Let us not waste our time. Here, this is V. Let's substitute straight. Here is 0 meter per second. V is 0 meter per second. So we have, sorry, the marker is going down. So we have 0 meter per second is equal to initial velocity is 15 meter per second minus, we are looking for A, which is the retardation, times what? The time given is what? 20 seconds. So we make this A the subject of the formula. So if we rearrange this now, we have something like this, that minus A times 20 is minus 20A. We have that minus 20A seconds, or let me just say minus 20A, or let me maintain minus A times 20 seconds is equal to minus meter per seconds. This will cross this equal distance and it becomes minus. So I just rearrange it. This is A, not 9. So if that is the case now, A will now become, we'll divide both sides by minus 20 seconds. A is now minus 15 meter per second over minus 20 seconds. I hope this thing is clear. Let me bring it up. Let me check. Okay, it's visible. All right, so let me clean some here. So let's so we have that A is equal to what? Minus 15 meter per second over what? Minus 20 seconds. Hope you know where I got this minus 20. This times this is minus 20. So we make A the solid the formula. And we have minus 20. So this minus sign will cancel the minus sign. Remember that this one is meter per second over second. So this will now become, if this come down, it will become meter per second squared. So we are done with the units. So 15 divided by 20. So we have something like this, meter per second squared. 20 divided by 15. 2 can go. Or 2 can go. If 2 go, we have 10. 2 divided 15 is what? 7.5. 10 divided 7.5. This decimal point will come here. It becomes 0.75. 0. What? It becomes what? 0.75. So the retardation is what? 0.75 meter per second squared. So let's look at the options and check if the answer is there. Option A says 0.75 meter per second squared is correct. But let's check the other options. Option B says 1.33 meter per second squared is not correct. C says 5.00 meter per second squared is not correct. D says 7.50 meter per second squared is not correct. So the answer is what? 0.75 meter per second squared. So the answer to JAMB 1994 physics question 5 is 0.75 meter per second squared. Our usual the question is simple, just for you to understand it, look at it critically. Before we end this lecture, I want to just give a few minutes for us to look at it. This will be our last question for today. As we look at it, listen to what I'm saying. I want to thank you for being with us in our today's class. Thank you very much. Please, if you have any question, we hold both on-site tutorials and online live tutorials. So for the on-site, the venue is opposite University of the Niger Teaching Hospital, Iyenu, Anambra State, Nigeria. While the on-site, the online live is showing on YouTube, Chetanna TV, and the Facebook at Chetanna TV, at Chetanna TV, at Chetanna TV 83, at Chetanna TV 83. The profile name is Pharmacist Isaiah Emmanuel Chetanna, in bracket, from eternity the school board. That is where the live lecture is streaming now as we speak on Facebook. We also have the recorded lectures posted on the same Facebook page. The page name is Chetanna TV. Please subscribe to the YouTube channel so that you will be part of these lectures. At the same time, follow and like my Facebook page and profile so you will be updated. You will be following the lecture. Please share this lecture with your friends. Recommend lecture to them. Inform them that every Tuesday for all level courses, every Tuesday, Wednesday, Thursday, Friday, and Saturday between 4 and 6 p.m. Sometimes it may end 5:30. It may also start from 3. Just target between 3 and 5:30. Target this period. Come online and join us. And join us. You have a lot to learn. And God will bless you as you do so. Gradually, we will also introduce pharmacology classes. At the same time, dispensing classes. Pharmacology and dispensing classes on Sundays and on Sunday mainly. In fact, on daily basis, just come here between 3 online between 3 and 5:30.